Hello, my name is Ana Paula Roldan Leon, and this is my argumentative oral exam for the course of Design of Bioseparation Strategies. For my case of study, it is needed to recover fasolene, a protein contained in common bean seed, given that a plant-based ingredients company wants to produce a high-protein powdered beverage in which a purity of 60% is required. For the question one, I have to say that in an industrial process of any size, it is overwhelmingly important to have a scale of mass and energy balance and evaluate it theoretically before initiate the process and during the functioning of it. For this, it's important to have a meticulous acknowledgement of the equipment and the compounds present on every mixture. Parameters like temperature, time, volume, and pH are need to be monitored for a correct efficiency and therefore assure the minimum purity required. This in conjunction with tests for the protein quantification and characterization that has to be done, such as the employed ones on this course, like BCSA, LSPH, chromatography, etc. This will be linked to the sophistication of the equipment and capital available. To validate the results, there are statistical tools for data management and also software such as SuperPro Designer, that is a professional simulator that facilitates the modeling, design, and optimization of integrated processes in a wide range of industry, including biotechnology ones. For the question one, once we perform a standardized laboratory process, we can do a scaling up with the data calculation. It is important to obtain a yield and have the supply information of the column. The size dimension information is the important one, so then we can do the calculation based on the scaling factor. This factor is based on dividing the dimension of the new column by the dimension of the original one, and this will allow us to calculate the ideal dimensions for the new one and look for a similar one on the market. For question 3, it is important to consider the volume. Since 200 times is a big scale of factor, it is necessary to evaluate a mathematical model of the chromatographic separation, but also an experimental evaluation of its parameters. The role of these parameters are explained on detail in Algebra 2006 work, where he asseverates that a successful scale-up is accomplished by keeping the residence time of the fluid flowing through the column. So in this way, the volumetric flow, the gradient length, and load are scaled to the column volume. Therefore, the column length is a design parameter, and the decision must be taken in function of the column size and the column aspect ratio. The column aspect ratio affects the pressure drop over the chromatographic bed and thus the bed compaction. And also, the time scales involved are going to be the time scales considered for flow, mass transfer, and dispersion. So this is why I will use a scale model on SuperPro Designer, for example, since this tool considers all of these mathematical and physicochemical parameters at the time. The use of this kind of tools is an important first step to consider for the formulation of any scale-up strategy. That will be all. Thank you.